Problem number 60. A thin rod of length 0.75 meter and mass 0.42 kilogram is suspended freely from one end. It is pulled to one side and then allowed to swing like a pendulum, passing through its lower position with the angular speed 3.5 rad per second. Neglecting friction and air resistance, find the rod's kinetic energy at its lowest position. And the second question, how far above that position the center of mass rises. Here we have to find the answer for two questions. In the first part, we have to find the kinetic energy at its lower position. So what is given in this question? You have a thin rod. So let's consider this is a rod, and this rod is fixed at one end. So let's see, this is the axis of rotation. Based on this axis of rotation, this rod is rotating. Consider this is a thin rod, and the length of the rod is given here as L, which is equal to 0.75 meter, and also the mass of the rod is given as 0.42 kilogram. Now what we are going to do, we are just taking this rod to a certain distance and we are going to leave. So what will happen, this rod will swing like a pendulum. So when it is about to swinging, it has the angular speed. That means you can see it has an angular speed. So let's see, omega, which is equal to 3.5 rad per second. When the rod will come in this direction, especially when the rod comes to the lower position, we have to find its kinetic energy. Clear? So for that, what we have to do, we have to use the formula for the rotational kinetic energy. So first of all, let's write the given first. What is the mass of the rod? The mass of the rod, mass of the thin rod, m equal to 0.42 kilogram, and the total length of the rod L, which is equal to 0.75 meter, and also angular speed omega is given here as 3.5 rad per second. Clear? Now what we are going to do, we are going to find the rod's kinetic energy. Rod's kinetic energy at the lower. So when the rod will come to the lowest position, we have to find what is its kinetic energy. As we already studied, the kinetic energy for the rotational body is given as half I omega square. But here we have to use the formula for the thin rod based on this axis of rotation. In theory, we studied if the rod have the axis of rotation at the end, we studied the rule for the moment of inertia for the rod having the fixed axis of rotation at the edge of the rod. We studied the rule is mL square over 3. This is the moment of inertia for the rod which is having the axis of rotation at the edge of the rod. So now what I'm going to do, I have to take this formula, I have to substitute here. So that means we have to take this and then we have to substitute in place of I. And then omega value we have, so we can take the value and we can substitute here. So when you substitute, you'll get the answer for the first part of the question. So let's substitute. Half multiplied by mL square over 3 multiplied by omega, which is 3.5 square, and we can substitute the value for the mass as well as the length. So what is the mass? The mass of the rod here is 0.42. So 0.42 kilogram multiplied by length here is 0.75. So 0.75 square multiplied by omega, which is 3.5 square, divided by 2 multiplied by 3 is 6. And here, let's see what is the answer. 0.42 multiply 0.75 square multiply 3.5 square divide by 6. I got the answer here as 0.482. 0.482, and the unit here is joules because we are just finding the kinetic energy, right? So its unit is joules. So this is the answer for the first part. Now for the second part, what they ask, when you take this rod to certain height, By the time what will happen, this rod will have the center of mass here. So when you take this rod to certain distance, its center of mass will be raised. That means they ask you to find what is this height of the center of how far your center of mass will rise. So we have to find the value of this height. So you can see the rod center of mass, because each and every object will have its own center of mass value point, right? So in equilibrium position, this is the center of mass. When you take this rod to certain height, so your center of mass will be a little bit rises. So we have to find the height, how far your center of mass rises. So for that, what we have to do, we have to use the conservation of energy principles. By conservation of energy, conservation of energy principle, potential energy which is equal to kinetic energy, right? And here the kinetic energy is nothing but the kinetic energy for the rotation. So we already studied the formula for the potential energy is mgh, and for the kinetic energy rotation we no need to substitute the formula, we already find the answer, right? So I can use the value of the kinetic energy, which is 0.482. Now we have to find the value of h, therefore h, which is equal to 0.482 divided by the mass multiplied by gravity. So here the mass value of the rod is given as 0.42 kilogram and the g value is 9.8. So 0.482 divided by mass is 0.42 kilogram multiplied by 9.8. Let's see what's the value. 0.482 divided by 0.42 multiplied by 9.8. Here I got the answer as 0.117. So I can write 0.117. So I can round it to 2-digit. So h, which is equal to 0.12 meter. So this is the answer for the second part. That's it. Thank you.